I'm Alyona Galyeva, and I'm one of the co-organizers of PyLadies Amsterdam. And I get used to do it usually with my colleague Demi, who is as well a co-organizer of PyLadies Amsterdam. And Debbie now is on her holidays, so it's a little bit of a strange feeling. So I know that she's watching now, so Demi, hello. Yeah, so let's start. Today I have two people who helping me to lead the workshop, and also let me briefly show what it can do. So now you have an ability to watch this video, and from the right side of the screen you have an Q&A icon. It means that during the workshop you will be able to ask questions. And if this question is relevant, it will be answered immediately. If the question is irrelevant and can wait, it will be answered at the end of the session. So right side of the screen, you have a Q&A. I think that's it. And for the bigger question, we have a special section of the event. So the brief agenda first, this the basic introduction and screen sound calibrations, and then the workshop with exercises with some pauses in it. And then at the end of the workshop, I just decided to have 30 minutes for Q&A, so feel free to ask any questions you have, of course, related to the workshop. Okay, so first let me introduce Luca. She will be helping us today. Just a second. Okay. Luca.
Hello, everybody. I'm Luca. I work with Alyona at LINKIT. I don't know what to say.
No, you won't.
Yeah.
What are you doing at LINKIT?
I work as a data engineer, and at the moment we are both me and Alyona are working in the same team to develop a full circle machine learning platform. And in my spare time, I like to go bouldering and play Dungeons and Dragons.
Cool. Okay, good. Thank you so much. And now let me introduce Ufuk. He will be the second helper today.
Hello, everyone. My name is Ufuk. I studied data science in Tilburg University, and from there I work at LINKIT as a data engineer. Soon we will have a project in FC Utrecht, which will be very exciting. In my free time, I like to play piano, and as sport, I do boxing. And today we will be helping you guys with your questions. Have fun.
Okay. So in the meantime, I do hope that you have time to visit this link and actually to already follow the instruction in the GitHub repository. They're really simple. Fork the repository, then clone the forked repository, navigate to the folder via terminal, and run Makefile. So I do hope that you were able to do it, or in the meantime when we are waiting, and I will do the same. So I just go to my terminal in the meantime and just run the commands, and we'll be waiting until the beauty of automation work for me. And then we start. As soon as conda environment will get it. Great. Okay, so I have a person who's trying to get in and got some strange code errors. 1 second. Until it's installed, I will troubleshoot it. Zoom just a bit. Okay. Minus. Okay. A bit. Okay. Okay, in the meantime, what happened? I will make the screen bigger as well. So I will zoom this part. So what's happened now? So as I mentioned before, the magic happens. So repository contains the Makefile, and actually make all magic commands do all the heavy lifting for you. While I was talking with you, it was working for me. And what is actually done, I can check briefly. So first, it's created conda environment to make sure that we are not using everything that is on this machine, but having one specific place. We install all things in this specific place, and we got it from there. And then we actually adding our conda environment as an IP kernel to our Jupyter lab, and it's starting Jupyter lab for us. The reason behind choosing Jupyter lab instead of just working with Jupyter notebook, because I see much more useful things and much more ability to do stuff with Jupyter lab than with Jupyter notebooks, plain Jupyter notebooks. So like the tip from my side, if you love work with Jupyter notebooks and you have never heard anything about Jupyter lab, try it. It's really good. Although for the future, I recommend to go and to use IDE. It can be Visual Studio Code is mine, or it can be PyCharm or any other that you have. Okay, so now everything is ready. Let's start then. Let me make it full screen. So welcome, welcome. I will go over it. Okay, so I will get it more bigger. Okay, so this is the short workshop structure. We'll have really brief introduction. Then I will go explaining why refactoring is needed, how to refactor your code, what prerequisites are required, how to write more cleaner, more efficient code in Pythonic way. We'll do some exercises. Then you have bonus links, and this is our Q&A time. Okay, so introduction about me. As I mentioned, I'm Alyona Galyeva. I'm Principal Data Solutions Engineer at LINKIT, and as well, together with Lady, organizer of PyLadies Amsterdam. And also, I want to note one thing that we restarted PyLadies Amsterdam chapter 1 year ago. So our first meetup was dedicated to test, and it's funny because today we will cover Pytest as well. So yeah, it's great to see that in one day we get back to it. Okay, so this is just the picture that we got from our offline events. One of the good picture from picnic events, and this was actually our official last offline event before the citation with commit developed. So yeah, that's what we get. Okay, and of course, if you have any questions, you can find me on LinkedIn or any other social media. So that was the brief introduction. I think I told enough. Let's get straight to the point. So the first thing is why refactoring is needed, and to define what refactoring is. I was searching through the internet to find the most suitable image, and I came across this. So first, I created plain and easy script, and it says .py, but if we're working with Jupyter notebooks, let's assume that it's IP and B. So we got it. Then we have, okay, we added another script. Then we decided somehow glue the scripts together. Then we said, okay, maybe we can add somewhere here, or a change here, something here, something here. Then I did this, of course, maybe another library, maybe another dependency. And on top of it, I forget to use virtual environments, or I forget to use conda. And then we go further and further and further, of course. And then it grows and grows and grows. And this is actually your end result. This is what you got. And actually, it's not the original thing to have it. So yeah, that's what we get in the real life. And I want to show you how actually it works if you work with the Jupyter notebooks. And this is what I've seen actually in practice a lot of time. So let me make sure that the kernel is correct, Jupyter refactoring, select, and then let me run this cell. So it can take some time to run it. Just to make sure that it's import all libraries. In the meantime, while it's started, how it's going with questions and answers. Okay, good. Okay. So it's loaded. So, and then what you do, usually work with CSV files. In real life, it can be different sources. It's not only one CSV file, it can be anything. And then what you got, let me make it a little bit bigger as well. Now I think it's big enough to see. And usually what I see the people doing, if they want to just read data, create data frame and create it by reading CSV file, they use this. And my dears, this is not the best experience ever, because if you use, we call this absolute path, then nobody else except of you on your own computer will be able to access this file. So nobody, only you will be able to do it. Okay. So for now, I will keep it as it is. If you have a question how to replace it, this is actually our workshop is about this. But usually we use things that called relative path. So if you know in which folder you are right now, you can check it with different comments. And one of them is actually, let me put it here. Yep. Oh, one of them is pwd, and you run it. So, okay, it show me where I am, and you also can verify it's here. So now you're in this folder, Jupyter, refactoring, and there's this all files listed. So if you know that you have, oops, a little bit. If you know that you want to read a file that is located in the workshop folder, we are in this folder right now, and your data is here in the data, then it's just easy. You just type the following. So instead of this long thing, you can just say, let me do it, data Boston housing prices. Let me read it. Yeah, and it read it and it works. And then you do def head. This is usually doing, so the normal workflow, you do some import, then you read the file, so you created the data frame, then you do something with data frame. It doesn't matter right now what you're doing with this data frame, so some transformations or whatever, you watch at this data frame and you give this a name def1, then you do def2, you do something again, then you go further and say, okay, I want to have all the columns standardized. So yeah, that's what I get. Okay. So you say, okay, now I have def3. Then you decided to drink some coffee or have a lunch. So you go there, then you return back, say, okay, what I was doing. Okay, I was doing something. Okay, I see that I do some transformation with data. Oh, by the way, I decided to write a function. Okay, so let's have this function. So it does something, I give it this name, this function, take a data frame, take a column that belongs to the data frame, that's just multiply the columns and return the data frame. Okay, awesome. And I say, okay, let's try to use my function. I have a data frame, new, I call it def4. Why I need to reinvent new names or something like this? Just call it day 4, day 5, and until the end of eternity, so you can play with it. Okay, let's do this, let's check. Okay, you see visually we got this column somehow. Run this function, and we remember that this is our day 3, this is our day 4. Okay, and now if I want to get back to day 3, I got back to it and say, oops, what's happened? I see that I have df4 that I changed, but somehow df3 changed as well. And imagine if we add here no virtual environment, no conda, different versions of operation systems. It became a really hard to maintain. So if you feel that it sounds like you, or you love to do, starting your exploration this way, like df1, df2, df3, giving really short undescriptive name without any extra comments, what you're doing, why you're doing this step, what you want to achieve with this step. This is actually what you get. So here we come to this particular moment when we start talking about the refactoring. One of the, let's say, really famous developers, Martin Fowler, he wrote a series of books, and one of them is about refactoring. And what he is saying about refactoring, that actually it's an essential technique to allow a program to be changed safely. So it means that you can modify some code and you get what you expected from. So the behavior of the program doesn't change. So if you have a Jupyter notebook and you do some data exploration, you create some charts, you create some histograms. So even if you change something, you expect to get the same results back. So if we get back to refactoring, it consists of making small changes that don't alter the observable behavior of the software. So that you got what you expect. So why do we need refactoring? First of all, in real life, you will work with the code of the people, with your colleagues, with your previous colleagues. And it's not one person who is working on a piece of code, but a team or even more teams. And sometimes you need, not sometimes, I think almost 45% or even 95% of the whole work will be reading the code of other people and trying to understand it. So first of all, why we do need refactoring? To understand the code. So you can read it, and without any extra documentation, you can understand what this code is doing. So imagine if you open Jupyter notebook of somebody else who, for example, now on holidays, and you see this df1, df, and you say, okay, let's try to read. So this person read some data, create a data frame, then this person do some kind of filtering. What is chess? Do I see any description what this particular column mean? Nothing. So how do I know? Okay, so maybe it's the name, maybe I can go and look somewhere, but it's really hard to define. And then what this person is doing, okay, this person tried to filter something, maybe. Is it a good way to filter or bad? I have no clue. And this is okay, rename is something familiar. Okay, string lower, of course, something familiar. And I see access column, so person replacing the name of the columns, okay, good. Then the function, what this function is doing. So you spend a lot of time actually reading the code of other people. And it's not only your direct colleagues, but the people who will reuse your code in the future as well, because your work as a data analyst, of a data scientist, of a machine learning engineer, of a data engineer involves all people in the ecosystem around you. Why do we need refactoring as well? To improve the readability of code. So we don't want to have this kind of code. It can be if you need to do something really quickly, but still it's really hard. The first person who needs to understand what it's all about, it's you. So we need refactoring to make it easier to enhance the code. And what do I mean by enhancing the code? Imagine that you want to do new ad hoc analysis, or imagine that your code is doing something and you want to add a new feature to it. Imagine you want to update something like new libraries, and if your code is looking good, if your code is, let's say, somewhere between clean and good enough, then it's much more easier to add something. And of course, to reduce time of bug hunting, because when you will be working with the different types of data, there will be inevitably things when there is something broken or something doesn't work as expected. So yeah, in this case, if you got code like this, it's really hard to understand where the problem comes from. So this is briefly why do we need refactoring. Also, maybe you heard about technical debt. So what this is actually, maybe it sounds a little bit like strange. It's a metaphor to describe problems with code design. But actually, the technical debt it creates when you do a lot of shortcuts. And these shortcuts can be due for some reason. For example, you have enormous pressure on the work and you need to deliver new analysis every day, or you need to deliver new charts every day, or you need to deliver new models every day, or something like this, and you don't have time to make it nice and good. So sometimes you see, okay, should I improve my code, or I can just go because the people ask me to do this? So there are always shortcuts that you will take. And when we're talking about technical debt, we always say that the technical debt is your borrowing against future. And you need to pay that off with refactoring. Is it bad or good to have technical debt? Yes and no. Almost each company in the world has some sort of technical debt. It can be positive, it can be viewed as a negative. So you have it as well, and you need to pay it off. And then the thing is, okay, so I heard there is something, it costs refactoring. We needed to have better code, to improve the readability of code, to make it easier, to reduce the time to find bugs. Okay, we have this concept of technical debt. We want to get rid of this technical debt in some way. So yeah, that's the question. Should I do refactoring every day then, or what should I do? And actually, there is a good question, and it's all about it depends. And when it's about refactoring, when you need to stop, I will start with the part stop when there is no ROI. And what do I mean? If it's millions of Jupyter notebooks that you used to write when you was a student, or when you used to write while pursuing different online courses, maybe you can get back to them, maybe not. Maybe it's better to invest your time in creating new notebooks with something much more valuable and in a more structured way. Maybe not. Yeah, we don't know. If you work and every day you do something in Python, if your work is about working around data or around different things, as well, remember you have this pressure to deliver new features. You don't have a lot of time to improve the code base. In this case, you see, is it important to take this particular piece of code and make it better or not? Does it hinder our performance of the whole code base or not? So it's all questions that you will need to answer. So also, when stop refactoring, if you started and you see that step is so big. So if you're saying, I have a Jupyter notebook and I need to refactor the whole notebook, maybe it's not a good idea. Maybe it's too much. Maybe you can just go through it and pick a small part that can be reused somewhere so you can improve on it and work with it. So how to refactor a code, the prerequisites. Let's go to the prerequisites. So first of all, to know what to refactor, you need to understand what are the issues in your code and how these issues can look like. That's why let's start step by step, just seeing what's there, which kind of issues can be, and then we will see how we can fix them. So one of the most controversial issues is comments. If you don't work with Jupyter notebooks, then you know that usually if you write a function, you provide a docstrings. If you write a class or a class methods, you provide a docstrings. And if there is something special, you can add a comment, but it's not, let's say, it's as well like the technical depth if you leave a lot of comments. If you're working with notebooks, it's a little bit different, because from what I see, a lot of data scientists or data analysts, they love to add comments and explain in each step what they're doing. And now I see that, let's say, in the market, there are like this black-white approach, and one approach say, let everybody use comments, they're good, they make the files readable, and another approach says something like, no, so if it's a piece of software, it should be properly documented, and there should be no comments, because comments are obsolete. So once again, it depends. If it's Jupyter Notebook, and if this comments really adds value, maybe it's a good idea to have them, or you can just use markdown cells and put all necessary information there. I think maybe it will be much more readable, much more useful and readable. So that's why regarding comments, if you see a lot of comments, or if you see a strange comments, they can really help or badly hurt you. And this is just example of this. For example, let's check this. Oops, I jumped again. Let's check this one. So this is our function that renamed the column names of the data frame. And I saw this comment: give new names to the columns by renaming the columns and make each columns lowercase, use access columns. I agree if this is your first notebook, if this is your second notebook, or you just copy paste a notebook of somebody else. I do agree with it. Okay, you can have these comments, but are they really valuable? Yeah, I doubt it. Then another option that I found, it was really interesting. So it says correlation with independent variable. Okay, so it's show me some graph, and then they say, note, models like a ref are not linear like this. You know, it's like, what is a ref? What do you mean by ref? So if you read this and understand, it's okay, but what about the rest of the people? So for those who will be reading your notebook. So for this situation with the comments, if you are working with notebooks, maybe it's a good idea, if you leave in comments, to leave good comments, or even move these comments to markdown cells. I think this is the beauty of notebook in this case. So think what you are leaving and if other people can read it actually or not. Then there is another thing, it's confusing names. And this is actually one of the popular one, because remember, of course, our like friends, df1, df2, df3, and all this like awesome ugly names that you can find. Maybe twice call can lead you to some thoughts that it's something that, but what is do is duplicate the column or it's like multiply. It's completely unclear. So confusing names, it's a big issue. And when we get back to the refactoring techniques, actually, I think I can say it right now. So one of the most popular refactoring techniques called easy rename. And it's more than 77% of the whole refactoring is just about renaming things. But we'll get back to it later. Then you have the thing, and it's called magic number. And magic number are awesome as well. So somewhere in notebook you have this without any explanations. What is this? So I assume val is value, good. And then somewhere at the other part of the notebook, like 20 or 30 cells down, you get this. Okay, and you say if val this print, and you like, what is val and what is 6? And we call these numbers magic numbers. Why magic? Because only magician can understand what do you mean by this number. Once again, if we get back to rename, maybe it will be a good idea to give it a proper name just for you to understand what 6 means in this case. Then we have the thing, and this is the biggest issue of Jupyter notebooks. And this is actually when you got this when you got this long, large code blocks and a lot of duplication. I actually understand where it comes from. So actually, maybe you just do something, then you try different things. In this case, it's about building different models and compare different models. So you have one model and you do some stuff. You have another model, you do some stuff with it. You have another model, you do some stuff with it. But the thing is that all this chunks of code, you're actually doing the same. They can be replaced by a nice function where you just give the name of the model and some useful arguments. That's it. It will be much more easier for you. And imagine when you do this copy paste, so you copy this part, you change something, it's really prone to the human errors. So you literally can miss something really important here. So beware of this duplication and large code blocks. They are really, really, really dangerous. So it's better to have some flow or logic and instead of this. And there is a thing is called poor formatting. When I first time came across this, I was like, is it really written in Python? Is it really Python? Like, what this? So, oh, if you want to have everything on one line, you can put it and just use semicolon as a split. And I was bitterly surprised that it doesn't look normally like Python, like this extra step. So the poor formatting can actually damage. You see, it works. So like it do what it's intended to do, but it's like really, really bad formatting. And that's why in the conda environments, we have all the, if I go to the conda environments, we have such things like pylint and the rest of it. It's a linters, then actually saying, checking your code and saying, okay, it looks strange, please check the distance. Is it okay? Is it correct way to write stuff? And yeah, so that's the thing. And of course, the most popular one, this is, I think, the thing that everybody has, even I can admit I have this as well. This is a zombie code. So if you have in your Jupyter notebook or even in your Python scripts, you have this, something uncommented. And if you see that it stays there forever, nobody uses it, then yes, maybe the good idea just to get rid of it. And we call it zombie code because it's actually the code that do nothing. That's it. So, okay, we heard about all these problems. We spot a lot of issues. It's not all, trust me, it's just like basic ones. So we can just briefly recap. This is the comments, badly written comments. These are really confusing names. It can be confusing names for variables. It can be confusing names for functions. It can be confusing name for classes. Then there's magic numbers that nobody have any clue what does it mean. And then this duplicated codes. And by duplicated code, what I mean, if you just look at it, you have regressor feed, you have prediction, you have metrics, and the same metrics, and it's again and again and again and again. And poor formatting, think over the people who will be reading this code, and also think about future you who will be reading this code. And you have the zombie code. So yeah, but it's like it does nothing. Definitely this zombie code is nothing, but this is the thing that you need to have. Yeah, that's what I think. So now we'll be going to the third part. It will be hands-on part. So yeah, let's check. Do we have any urgent questions or something? Luca, Ufuk?
No, not right now.
This is also the question, how to write cleaner and more efficient code in Pythonic way. There are a lot of information in the internet about it, but it's always hard to find what is clean code and what is more efficient code and what is Pythonic way of the code. For me, it means that use everything that you have for the language. If I need to write a function and I notice that it's too many lines of code, for me, it's a sign that maybe I'm trying to create something that was already created by somebody else. Maybe I just need to go to Python built-in libraries, Python built-in functions, or yeah, of course, and functions from the Python built-in libraries, and to see where can I reuse it. Or what I usually see, what I often see when you have for loops inside of for loops inside of for loops inside of for loops. And if I see more than 2 for loops, is as well a sign that something strange happening here. So yeah, Then there is another thing. As I mentioned at the beginning regarding refactoring, it is not something that you just do for fun in your spare time. Of course, you can do, but I mean, on the workplace during the workday, it's always really hard to find this time to do refactoring. That's why if you want to do it, you need to concentrate on something small. So when we're starting refactoring, we have the typical workflow, and it looks this following way. So first of all, we should answer to ourselves, is it refactoring really needed in this particular situation? Is it really needed or not? And it's not. If it's something not important, then concentrate and do your everyday job. Then the second thing, Git, conda, or virtual environment are your best friends. Always try to strive for reproducibility. Always try to separate all the concerns that you have. And Git, it's like a magic actually, because it allows you to travel in time. For example, you did something, then you miss a part of it, then you broke something. You can always get back to that particular moment in time when everything was working. So Git is really magic. Conda environments or virtual environments in Python, this is your best friends. Like with this event, for example, what we can say, open the Jupyter lab and run on your machine, and then it will not work because you don't have all libraries, you don't have the same version of Python as I. So if I don't have a conda environment for this particular workshop, it was really hard for you to follow because it will give you a lot of errors. As you don't know what libraries, which version of library should be installed, how they should be installed, how they work together. That's why I highly encourage you, even if you work with Jupyter notebooks, please do this. So use it, conda environments or virtual environments. In our case, what we have this conda environment that was created, and it leads all, this is the name of our virtual environment. Oh, sorry, yeah, conda environment. And then the list of all dependencies that we have for this particular workshop as well. Why I love and why I prefer conda over pip, over virtual environment, because with conda you can install not only Python libraries, you can install as well libraries, we call this third-party libraries or third-party dependencies. I give an example. Recently I used to work for a time series analysis project, and it was for this project we used Facebook Prophets library, and this library has a lot of dependencies. And if you try just to install this library, for example, using pip install, this is the standard way of install different libraries in Python, then you will be doomed, because to keep this thing running, and it's pretty heavy. I mean, this library is really hard to get it running and to get all libraries installed in particular order. In case with conda, it's really easy because conda manages this for you. So you don't need to think about which version of Python, and you don't need to think which version of libraries. So it helps us a lot. Okay, then you think, make a copy of a notebook you're going to refactor. Always make a copy. It will cost you only 1 second, but if you made a copy, and imagine that you do something really bad to your notebook, you can always get back to the original one and work on it. So please keep it as a reminder for yourself. If you're starting refactoring, whether it's a notebook, whether it's a script, if it's a notebook, create a copy of it. And before creating a copy, I encourage you to run all the cells and to see whether you have any issues. A lot of time, Jupyter notebooks, I see all these things where the lines are messed up, and you have the first cell run, then it was another cell run, then it was another cell run, then it was another cell run, and actually you don't have nice ordered cells, but you have a mess. The positive part of, for example, I don't know, I'm not a heavy user of Jupyter notebooks, so maybe you can share your experience later. But what I noticed, what we have here at Jupyter Lab, you can actually move your cells, and it's awesome because if you need to replace something, you just keep this cell, you drag it to the place where it should be, and it's much more easier. Maybe that's available with some widgets in Jupyter Notebook. I don't know. Yeah, that's what you have. So copy notebook, make sure that the whole notebook run and work as expected, and then you have cells that working in order. And then there is this thing it calls fix the seed. And why do you need the seed? If you use NumPy, or if you use any other libraries that is dependent on NumPy, even like pandas or like TensorFlow, Keras, and the rest of it, you really depends on the random number generator. And we call it pseudo random number generator. Yes, I did it. But if you, so for example, when you train a machine learning model and you do a train test or validation split for your data set, there is a seed in it. So it gives like it brings some randomness. And if you don't fix the seed, then what you get at the end, and next time when somebody else will use your calculations, will use your code, they can get different results. And this is what we don't want to have, because we want to have things reproducible. How to fix the seed is really simple. I will show you in a minute. If you work with Jupyter Notebook, I highly encourage you to predefine a layout for the notebook. And what do I mean by this? I mean, so if your notebook is about like data exploration, then it's much easier for you to define which, let's say, to define like a skeleton layout for the step that you will be doing. And you can say something like, for example, I don't know, let me add. So you can say, you can start like first function will be load data, because that's what you're doing usually, something like this. Then you say, okay, what's the next step? Then I need to describe the data. So I want to have at one place information about, I don't know, like basic distribution of the data or whatever. So you say, for example, yeah, like describe data, whatever. So you can call it in your own way. I edit pass right now, just not to make the code breaks. Then you can do, okay, what is the next step? Then you will go to clean your data. So, and in the cleaning of the data, it can be checking your checking variables, checking whether there is any problem with like any data types. So there are a lot of things, but imagine if you have empty Jupyter Notebook, or you have Jupyter Notebook, at least where you have this like steps, so you know what to do, what is your next step. And for you, it's much more clear what should be in this particular section of the notebook. That's what I mean by define a layout for your refactoring notebook, actually. Then, okay, pick a chunk of code to refactor. And then, for example, if you create a function, write test for this function, run test, if success, git commits. So we will do it in, like, I assume 2 or 3 minutes. So be ready. If you get your test fails, update your function to make the test pass, and then git commit again. That's why the git, as I said before, this is your time travel machine, and repeat. So before coding, I want to have a short exercise for you. So, oops, up. Yeah, it goes a little bit airy. So this is exercise 0. Why 0? Because we are Python developers, so we start everything from 0. So this is the basic exercise. So we have 2 notebooks in notebooks to refactor folder. So here it is. And I want you to have your time and just take a look at this notebook. Like, let's have like 7 minutes to it. And I just wonder whether you can recognize some of the issues we mentioned before in the code for these 2 notebooks. Is the goal of this notebooks clear enough for you? Is the structure of notebooks clear enough for you? Just to make sure that you can spot the issues. And by issues, I mean zombie code, unclear names, no particular structure, magic variables. So just take your time, and this will be before we start doing other coding exercises. So take a look at it. I think, assume let's keep 5 minutes. And in 5 minutes, just take a look at it. Okay, so finally, time to roll up the sleeves and start hands-on part together with me. Before that, I just briefly read all your questions about Makefile, about some issues with Makefile. So the thing is, Makefile just help you to automate the processes. So instead of doing a lot of steps and just following some instructions, I create this file, I run this command make, and then the command that I define for myself, it can be make and then whatever you want, and you have it. If you're working on Windows machine, there is one thing. So the Makefile that I've written is created to work using Bash. So if you're on a Windows machine and you don't have a Linux subsystem on Windows installed, there is a workaround how to get it. That's why in the here in the GitHub description, there is a thing. So if you're a Windows user, you can install git bash, and it allows you to run very simple rudimentary commands. And in this case, your Makefile works if you're using git bash, but you need to install it before. Or if you, so if you have Windows and it's later than version 10, then I highly encourage you to install a Linux subsystem for Windows. It will be much more easier for you to work with it then. Then I also saw some questions about like I have Anaconda, maybe that's why it doesn't work. Actually, Miniconda and Anaconda, it's the same thing. The difference between that Miniconda is much more lightweighted version of Anaconda. Anaconda has more than 3 GB, different libraries of all sorts that you can use for data science, machine learning things. And Miniconda has the basic bare minimum. But both Anaconda and Miniconda has this conda inside of it that do the magic for us. So that was the brief recap of this. And I will get back to this part. Okay, so yeah, okay. Okay, good. So now we are going straight forward to our first exercise, and we are starting with refactoring techniques. As I mentioned before, the most popular refactoring technique is rename. And we can rename almost everything. We can rename variable, function parameters, class attributes, class method. We can rename everything. And I assume that you have some time to take a look at the notebooks. So let me open a new browser tab. Yeah, let me just open it again. So let's assume we decided to refactor this beginner workshop. We have the first step when we read the data, then we have the second step when we, the first step when we just assign the path to the data, the second step when we read CSV file and we save the data as a data frame. Then for some reason, they decided to transpose it in order to see all the column names, maybe because they don't know that there is a function, this one, I will show you, that allows you to see all the columns you want for pandas. Oh, sorry, I got a little bit too far. Yeah, so there is a thing, it calls PD set option, and you can show how many columns you want to see and how many rows you want to see. So actually this option allows you to show or the whole, to see all the columns, so you don't need to do any transpose. So it's much more easier with this. So we see that something happens in this part. It's pretty hard to read, although there are some print statements. So we see that there is attempts to do some cleaning, and actually we have a column called budget. And if in this particular column the budget is lower, is budget equal to 0, then we just remove this line. Then as well we take a look at the revenue, and if it's less than 0, we as well remove it. And actually see what's happened. They have, this is the number of rows that they have before, and then just by each step they remove almost like 1/10 of the whole node of the whole data. So is it a good way to do it or not? Rather not, but anyway. So let's assume that we decided to work on this particular notebook. So we make a copy of this notebook and we start to write in the code. So we have this 2 functions. Oh, sorry, wrong button. So first thing, as I mentioned, rename. And if you have this chunk of code that says rename, that says x, df, df1, we can just rename them and we can do it with ease. And we say, okay, this is a file path. Let's call it this. Then we know that we are working with pandas. We know that we created a data frame. Then we say, okay, this is the movies, and we read the CSV file and save a data frame. This is a pretty big one. We define low memory files for it. And actually, if you work often with read CSV, take a look at the documentation, please, because while reading CSV, you can have a lot of parameters. So you can pass a lot of arguments. For example, if you're reading data, you can immediately define which column has a date time, so you can immediately parse date time. So please take a look at the documentation, because a lot of people use this comment only to insert file paths there, and that's it. And actually, there are a lot of things, a lot of parameters that you can add here. And then if you say, if you gave the proper variable name and you say movies big budget, and you define like the movies with a budget that's more like it's millions or it's 30 millions, I assume it's dollars, then it's completely different story. I'm not talking about what is a good way to use log or just to use this filtering. Let's keep it for that moment. We are talking about just variable names. So, and look at this, you have x, df, df1, or you have here that reads like a story, file path, movies big budget. So immediately you know that in this variable, movies big budget, you have maybe the films that has budget that's more than 30 millions. Okay, then we understood about names. Then we want to do something with this, because we see that it's repetitive. One option how to do it, we want to write function that will take some filtering condition, and that will return data frame to us. And if we write this function, we can manually test it, but it's really cumbersome to do it. That's why I want to emphasize how tests are important. So we get back to it. So, but about function first. Let's check about renaming functions. So we are going to write a function. Let's know how to use and write functions in a more better way. So what we have here, we have a function, we call it myfunc. Okay, it takes a, b, and it returns a lower, b upper. Okay, that's it. Maybe with some time you will forget what is a, what is b, what to do with it. So maybe you can rename this function and its parameters and say, okay, def, for example, mix lower uppercase instead of myfunc. I'm not saying that is the best name, but just to start from something. And then you say first parameter, second parameter, and then this is what the function returns. So you know that A, this is the first parameter, B is the second parameter. But there is a thing I highly encourage you to take a look at it. It's called type hints. You can use it, if I'm not mistaken, starting from Python 3.6. And this is a really good way. So you can immediately show what type you want to use. From one side, it looks a little bit long in comparison with this part, but just take a look at it. You're saying you're taking the same name of the function, mix lower uppercase, and then you say first parameter, and then you add column and you define the type of this particular parameter. In this case, it's string. We use str for string, int for integers, float for floats. And if you want to use something like list or dictionaries, you need to import additional built-in library. It calls import typing. So here you have string, second parameter string, and this magic thing, it actually shows you what your function returns. So if you take a look at this function, you can see immediately that this function will take 2 parameters, both parameters as strings, and then your function will return string as well. Then you add in here the docstrings, like what does function do? Concatenate 2 strings, cast the first string to lowercase and the second string to uppercase. The question is, should I write the docstring if I use the type hints? Please do, because from this documentation you can generate with Sphinx or other tools, you can generate automatically the documentation that will be in a human readable way, so everybody can read it. The first thing, the second thing, that type hints as well. In our conda environments we have black, and we have mypy, if I'm not forget to add this. But at the end of the notebook, I added the link to read more about pre-commits. I don't want to spend time on it right now, but it's as well really, really useful. And actually with mypy, you can check, for example, whether the types that you added here, whether they work. So you will know definitely the function works as expected. So the thing is as well, so you say, okay, maybe what if, like, okay, I said that this is string and this is string, but if somebody else adds numbers instead of it, our function will throw us an error because lower and upper works only for strings. So how can I prevent it? Like kind of prevention. So you added here the cast into a string. So you cast the parameter to a string. So there are a lot of things what you can do. For some time you need to stop, otherwise you spend too much time on doing like make a function better and better and better. So we need to stop at some moment, but you will see how we can start with really simple and easy function. Then we can expand the name, giving it proper names, and then we can add a docstring. It's a really rudimentary docstring. It has only description of what the function is doing, and then even you can add some like prevention mechanism. So, my dear, it's your time. You have this function. It says refactor me x, y, z, and return this. It looks a little bit weird. Let me put this function here. So now you see it. So it's your task now, 5 minutes, trying to refactor this function. And we are using rename. So the first step, rename this function as you want to like give some meaningful names to the function, maybe rename parameters if you want, then add one docstring to explain, trying to explain what this function is doing. Like it returns nonsense, but at least for now, just for a learning reason. And then add type hits, try to add type hits. We don't have lists or dictionaries here, so in your case, think what it should be. Or do you want to have strings here? Do you want to have integers or floats? So take a time. In 5 minutes, we get back to it. And then we go to the next type of refactoring with writing tests for your function as well. So this is your exercise. And in 5 minutes, I will show you how you can solve it. Sorry if I'm too fast, but anyway, we need to keep our time. So we have a function refactor me. It takes x, y, z, and it returns something. So this is the question, what types we want to have here. Imagine that we decided to have integers. So, okay, first we say what this function is doing, it calculates something. I don't know, some magic number maybe. Let's call it, I don't know, calculate magic number, like this. Regarding the name of parameters, should we rename this or x, y, z, good or not? I think for now we can keep it just x, y, z. That's it, just for the sake. But in the future you can rename it as you want. So, and now I just copying the return like this. Okay, so at least you see that this function calculates a magic number. We don't know, maybe it calculates 42, maybe not. So we have a function. Then we need to add a docstring to it, and we need to add a type hints. Let me just copy the function. I copy just to let you see how you can evolve your function. So we need to add a docstring. Okay. As I mentioned before, it's really rudimentary one. There are different types of docstrings that you can use. Somebody loves to use NumPy style. Somebody loves to use Google style. I'm more fond of the Google style. It looks like this. So you have the string that defines the function, and then you say something like args. You do like args, and then you define which arguments do you have. You define, like, for example, you say x, it's integer, and then you give the description for this. Then you say, okay, I have next, it's y, it's integer, and I return some more information. Then you have, so we have all parameters covered. Then you have, okay, then you have what the function return, you say return, and then you describe what the function is return. And if you handle any errors, you can add even like raise errors, errors, yeah, errors. And you go for it. So for now we say, so let's say that the function calculates a magic number. Maybe we write in a game, I don't know, maybe something. So that's what our function is doing. Okay, and that's what our function is returning. But also we need to add type hints. So we decided that our function parameters are integers. That's why I'm saying integer. I expect y to be an integer as well, and I expect z to be an integer as well. And then we need to add what our function return, and I suppose that my function return integer. That's it. You can improve it further, but it's not the point. So the point is, about rename, what do you need to remember about the rename method? This is one of the most powerful and most easiest from one side. Refactoring technique, you can rename almost everything. One thing, if you do renaming and you have or a function or a variable that use all over your notebook, don't forget to replace it. I assume there should be something that allows you to, maybe like a search or something that allows you to highlight the name of the function. Do we have such? Okay, let's check what we have for Jupyter Lab. It's all cells, outputs, kernel. Okay, maybe it's somebody else, other place. I mentioned that I use IDE for development. So in this case, in IDE, what I can do, I can actually highlight the variable and click and say, first of all, show all occurrences of it, and they say change all occurrences if I need it. But be cautious, because if you have a function with some similar names inside of other functions, you can create a mess. So in a nutshell, rename, it's a really powerful technique. It's always hard to come up with good names for functions or for variables. Think about it, think what would be useful for you, and also try and keep them not very long, because like calculate magic number, maybe we can even just shorten it like calc magic. However, now maybe I rather go with calculate. Okay, so this is about this part. The next powerful technique, refactoring technique, it calls extract. So what we can extract variable, function parameters, class or class methods, and other stuff. So in this case, how extract works, this is an example of it. Remember our movies. So let's assume that we have movies valid budget. So we say, okay, once again, naming. If we check how they call it here clean movie data data frame. Okay, and then they take another variable and say again clean movie data frame. For me, clean movie data frame, I don't know about what it is, which part of the cleaning. So I prefer to use, remember, rename, more powerful names. So you say movies valid budget. It means that it contains all movies, the budget of which is not equal to 0. However, I don't see anything about cleaning data, so I don't know whether do we have any missing values, do we have any strange values like none or minus or something like this here. So it's hard for me to say now if we just remove all rows where the budget of the movies, if we just return all rows where the budget of the movies is not 0, maybe not all rows will be valid, but let's assume that it's valid for now. So in this case, how we can work with this, you can extract the variable. So what's happening here? You say, okay, first I want to define what's the valid budget. Valid budget, it's when movie's budget is not equal to 0. And then, so for you, it's more like a Boolean. And then you say, okay, movie's valid budget, let movie's log valid budget. And if you compare this line, and if you compare this to line of codes, for me, the second one is more informative because I see that you create some kind of filter, in this case is a valid budget, and then you actually create the new data frame, movies valid budget, and I see how you filter information. So here we write some functions, remember, and then if you want to test these functions, it's pretty hard to do it. What you need to do, you need to say, okay, I want to call my function calculate magic number, and then I should say 1, 2, 3, and also I want to see, let's call it, I don't know, like magic. So you do this. Oh, I want just to assign it. You run it, you want to see the output of it, you want to make sure that it works, of course. Okay, so magic, calculate magic number. Yeah, then let's show what the magic is. It's 14. Okay, what if I say the next step? Okay, what if I pass here 11? Here I pass -2, and here I pass this. Whether it works, you run the cell again and say 29, and then so I can keep doing this for ages. And this is actually not the most good way to do it. That's why for all functions we need test. So if we take a look at our extract method, we can extract the variable, we can extract the function as well. So in this case, we will just create the function. But if each time we will create a function, we will test this function manually like this, it will be really hard for us. That's why we come up to test. We have a really cool library. It calls Pytest in Python. I'm a heavy user of this library, so actually it allows you to write all kinds of tests. Usually I don't work directly with Jupyter notebooks. I work with Python scripts, and we just extract necessary information from Jupyter notebooks. We convert them to the Python script and work with them. So it's really easy to run a Pytest there, to write tests and run Pytest. With Jupyter Lab, Jupyter notebooks, there are different libraries available. Almost all of them are based on the Pytest, different extensions. I didn't investigate them all, but what I found, I was looking for some kind of magic for Jupyter notebook in order to run tests without saving tests in separate Python script and running this test. And why I love Pytest, because it takes away all the complexity and it allows you to write your own tests from scratch from the very beginning. Before we had different libraries, and it was really hard to start write tests. So thank you, developers who created Pytest for us. So now what we're going to do, before extracting a function from our Jupyter notebook, we wanna do two things. We will have simple function and we'll have two tests. And what I want to show you, this is how it works. So this is line, it's to run Pytest. Clean is to, to clean the resources, and VV means verbose. And on the top of our notebook here, we have import. We actually import our Pytest. This is the original one, and IPytest. This is the library that allows us to run tests inside of the notebook. As I mentioned before, there are different libraries, but let's stick to this one. Okay. So if you want to write test and run test together with function in one cell, just use this. I will show you how this VV works. So actually, you create a function. You say dev say hello, and your function, let it returns a string hello again. And what if I want to test my function? Every test should start with the name test. This is, it's a rule. So that's why if you create a test, actually test is the same function. And now we are talking about a very particular kind of test. It's called unit test. So you have a function, your function is a unit, and you can test this unit with your unit test. The test looks the same as the function, but its name has test in the beginning. While we're writing functions, we keep using dry method. Dry method means don't repeat yourself. So you want your function be concise, clean, and giving you what is expected. When you write tests, we prefer to have tests wet. It means that I want to have as much information as possible, and I want to get as much information as possible from this test. So we're saying, okay, we have a function, say hello. So there is a convention. If you want to test this function, let's start from the simplest one. You're starting with test underscore, then add the name of the function you're going to test. In this case, it's say hello. And then with underscore, add information that you need. For example, I assume that I create a test, so I know that it's really simple function. If I call this function, it just returns me the string hello again. So I just wanna make sure that I got from the function what I want. So I assume that my function is a success. So I say, this is a magic word, assert. So assert that say hello function. So you put your function, you call this function here, equal to hello again. And then we say, okay, and what if I want to see the real failure? Can I see the test fails? And I say, okay, failure. So I call my function say hello. I know, or I expect that my function returns hello again. But I decided to see what will be if I say hello again from the small one. So let me first remove this VV and just run the tests. Woohoo, I got failures. And it says failures. So this is thing it calls test report, and it says it's failures, and it show me exactly which test failed. And it say, okay, test say hello failure. So I know immediately that there is a problem with my test say hello failure. And then it show me yeah for error, and it show me this is assertion error, and it show me exactly where the error is happening. It show me that this is what was expected from my function, and this is what I got. And it is well saying me here. So test say hello failure, assertion error, assert hello again, don't equal to hello again. And also on top of it, I have this .f. This is, you see the number of tests you have. In our case, we have 2 tests. So here you have test 1, it passes, that you get dot, and then you have test f that didn't pass, that you get f, so it fails. And if I add here VV, so, oh, wait a second, it should be there. Then it gives you more information. VV stands for verbose. So in this case, it say, okay, I collect 2 items, and this test say hello success passed, this test say hello failed. There are other way we can add handling errors here. So for now, we skip this part. Let's see what we can do. So we are working with our library, and then let's check how to test it, how to write, how to extract the function, and how to test it. Here we have say hello. This was a basic one, and here we have an actual data frame. And this is what I found really confusing, because if you want to write tests to test a NumPy errors or matrices, or you want to test data frames, the pandas actually has in its library some functions that we will reuse. It's actually PD testing assert series equal, or PD testing assert data frame equal. So actually it's replace us this part. So we're not saying explicitly assert. The function from pandas will handle this for us. Yeah, I see it here. It's like say assert. And actually, there is no lot of information in the internet about how to test pandas data frames. So if you write a function that do something for a data frame, let's check. So what we want to extract a function that multiply columns. So for 25 for some number. So, oh, that was, I need to remove this. It was left. So I created a function that calls multiply columns that take as an input pandas data frame. Here you have my type hint. So after column, it's the same like integer, string, or float. Then I have the column name. It's a string. And in this case, function returns me a pandas data frame. Also, I do this, df.copy. Why I do this? Remember, if you pass a data frame inside of the function and you do some operations with data frame will be mutated. That's what we see in the beginning of our workshop when we will be working with data frame number 4. Then from data frame number 4, we updated. So we expanded data frame number 3. And then when we check the data frame number 3, we notice that actually, yeah, this data frame was expanded. And so we mutated original data frame. So that's why I do copy in order to prevent this mutation. And then I say, OK, this is updated data frame. And this is our column name. And then return updated data frame. OK, so then regarding the functions, this is what you have here. We need to write tests. And when we write tests, we're always thinking about the positive cases. That's when you give something to the function and it returns something back. And it returns what you expected. And sometimes we can as well pass something that is unexpected, or we know in that the function return an error for us. That's why we need to write functions, test functions, tests that cover different use cases. OK, so in our case, we had this. We extract this function from the Jupyter notebook, multiple column, and we start to write tests. There are different ways how to do it. I will show you the basic way to work with it. So in this case, we're saying, remember our convention test. Then we get the name of our function, in this case, multiple column. And then we're saying what we are doing. So we're saying we are multiplying it by 2. Oh, now I got where there was the mistake was. OK, let's say by 2 and OK, so now I see, so I have here the multiplier. Actually, it was the elements, how do you call it, multiplier. And it was an integer. And actually here, there was this, OK, 25. Now I see that I wrote a function and I completely forgot about this multiplier. And then actually what it does, oh, let's write it right now so we can just replace 25 with multiplier here. OK, so now if you will run the first test, it will fail because now it doesn't correspond to reality. But anyway, let's go. Let's see. Now we see that 2 tests have failed, 1 test have passed. So what's inside of the test? So we want to test our function multiply column. We decided that we want multiply by 2. So to test our function, we need a data frame. So we are creating this data frame and we call it input data frame. And we say, OK, input data frame. This is our the first row. This is the second row, and this is the column names. And then you go and say, OK, now I will call my function, and this will be my test df. So I create the data frame. Calling my function multiply column. As an input, I have this data frame that I just created. Then I have a column name, and then I have the multiplier that I want to get. And what I expected to get, actually the pandas series from it, because I pick only one column. in this case, column B. So as we work with column B, and so this is our first row, this is the second row. So to get this, let me check what our function should return. Let's keep it outside for a second, because I found a mistaken code and now I'm debugging it live. Okay, oh, of course, name error because I don't show the input def. Wait a second. Let me run it. And then what I want to see, yes. Okay. Let me skip. Okay, it's failed, and then I want to see it. Let me see it. Test df to see. Okay, so it should be series. It should be 416. Okay, 416. And for the second option, it's for this one. It's 4. This is 16. And for this one, if we're using this for test df, this should return us this. Yes, so we should get -1, -2. Good. -1, -2. This is what we expected to get. -1 and -2. Okay, so get back to our test. Let's run our test. Now we have past. So what's happening? What was there? Originally, I created the function. And when I created the function, I assumed that function takes 3 elements: data frame, the column name of the data frame, and a multiplier. And when I was created the new data frame, I forgot to replace multiplier. Actually, I forgot to replace a number with a multiplier. That's why I got this error. So my first positive case, I expect that I have a data frame and I want to multiply the second column, column B, by 2. So what I get in return, it will be pandas series because it has only one column with the name B. And this is our assert statement. So this is actually this assert, but in a pandas way. So what it's doing, it's actually testing that the series that I created by hand and the series that my function returns are the same. And if it matches, you get passed. And then here, this is the same. I test another case and say, if I want to multiply in column A and I want to multiply it by -1, this is what you get as the end result. So you got this series and it matches, so you got passed. And then what if I want to have a data frame that doesn't get this column name? What if I just pass the C? It's not here, right? So what will be there? So if I remove this part for now, if I just keep it as a usual test, I have input df, I had test df, so this is test df, then I get some, I don't know, like expected df, let's call it. Let's just see how this fails. I don't know, like pandas series, I expect to get from it. Let it be 1, 2, whatever. And then say the name of the column was like A, whatever. Let's just check. And if we add PD testing, we want to test this part. So we assume that C exists. I just want to see whether we got an error or not. This is asset, series equal, and then it has test df, and you compare it with expected df. So what if I have this? What I get? Let's check. I got failed, and it says to me, so it gets a lot of things because it gave me key error and showed me C. So in this case, I know that column C doesn't exist. So I was not able actually to call this column. So if I know by hand from the very beginning that this test will definitely fail, I can actually handle it with an error and say with Pytest raises key error, because we saw that it's a key error. Let me just run it. And you see it passed. Why? Because we expect to get key error and we got our key error. So it was a really long, big piece of code, and also Siri got in time. I have this exercise. Let's see. So we have these things from one side to say, wait a minute, why are we doing this? We can just pass this budget and movie data not equal 0 and revenue not equal 0 in one logical function, say just end. But imagine if you want to add more and to have the thing that says end, it will be too long. So we just keep it as it is. So this next exercise, so the goal is you have this tons of code from our Jupyter notebook. You need to extract a function from it and write three tasks for the following lines below. I see that time really limited, so we'll speed up a little bit and I will finish. It's really like not a lot of information left. I have in the workshop, I have a solution folder as well. So please first try to solve it on your own. If not, go to solutions and check the solutions. They're here for you. So yeah, because I also want to have some time for questions if we have. So let me pause this part and cover the rest. We're almost at the end, just to show you another refactoring methods, and there are even much more. And if we have time and no questions, I will cover this part. And if not, you can try to solve it on your own, and then as well try to first solve and then take a look at the solutions. So far we covered two refactoring techniques. It's rename, the most powerful one, and extract. We have as well a refactoring technique that calls inline. You can inline a lot of things, and this is just an example how you can do it, and it's really easy. So instead of doing this, like file path, assigning this file path to the path, then to say movies, read CSV file with file path, low memory files, sometimes it's just easier to replace this file path with what you have. And in this case, you get movies, video read CSV, the name, so you don't lose memory, Python memory on extra variables or extra objects. And that's it. And you can do the same for a function. Imagine you have a function that tries to do a lot of things, and then you just want, okay, I don't need it. It's do completely nothing. I just want to do inline. Then we have move. This is as well one of the most powerful techniques that we have. And with move, you can move a lot of things as well. You will move variables. You will move functions. It's just an example, a really dumb example, because it have only passes here. For example, you have you train a model, one of the regression model, you decided to create a class around it. So you say, this is my regression model, and then you write some class methods for it, or treat it as a functions as well. So they do something, and then somehow you decided to edit this particular method for it. Why? I don't know. So then maybe if you have two classes and one that do actually my regress model, another one that do some classification task for you, maybe it's a good idea just to move that classification where it belongs to. So this all refactoring techniques are not limited to one particular thing. So there are different options. That's you can do. And that's it for now. So let me check what are the questions, if there are any question that I can answer you. And here I have a lot of things added. So this my two articles, medium, they're really short. It's about Jupyter Notebook refactoring, and I'm currently writing the part 0, and soon it will be published in 2 days. Then there's a really powerful link. It's a refactoring catalog. So where it's not written in Python, but then you see a lot of different refactoring techniques. There are tons of them. And this is as well. Then it's really helpful. It's data science workflow, and actually covers all steps of the data science workflow and what you can do it, how you can handle it. So smart people read this for us as well. Then these 2 articles are really powerful because they are all about structuring and automated workflows for data science projects. So take a look at this as well. So these are the things that can save your time, like, for example, Makefile that are created for you. And then there's a powerful thing called like unit testing, linting, and CI/CD for a Python project. So it's all of this. Then there is a really nice videos about reproducible data analysis in Jupyter, created by the author of data science Python book, Aurelia book. And also I by accident came across this wonderful repository. So this is a person, it's a guy who creates like this clean code for data science projects. Yeah, so that's a lot of things. Let's take a look now for a question, because I already have stolen more than 15 minutes of your time. I apologize for that. So yeah, so questions, what do we have for questions? Luca, Ufuk?
Oh yeah, there is one question from Cecile.
Okay.
She asked, or she, is there some checklist with the most common tests to run?
Good question, Cecile. Do you mean the checklist for the commons, or so with the most common tests to run? So like, are your question about this, like how to do this, or your questions is more specific to the exactly like all these different types of tests? Because we covered really briefly only unit tests, and we have other different type of tests. Could you please elaborate more? Just like, do you want to checklist with commons, just how to run tests, or what it's all about? Just a little bit more information about this. I will highly appreciate it. And as well, maybe sorry that I scared you from the very beginning with all this like tests, but it's really powerful, because then you can write functions, and if it doesn't work, if some of the tests failed, you see where it's failed, so you know what to change in your function. So it's really powerful concept. Yeah.
So still elaborated,
Yeah.
and they say the different types of tests or things to test.
Now we are dealing only with unit tests, and so you have a function, you write a function to test the function. This is really what you're doing. It sounds weird, a function to test a function. This is a unit test. Then you will have different types, like integration tests, when you want to test a little bit more than only one function, the differentiation tests, and a lot of that. So there are different things. I think what it can do, if you're just starting doing tests, think only on the level of unit tests. So you write a function and you want to test your function. And when you want to test your function, think always or like cases where your function should work, and all of the cases where a function doesn't work. Yeah, so I assume it's answering questions. So what we have, in the beginning, I mentioned that we have pre-hooks. And pre-hooks, it's like your safety net. If you write a piece of code and you push it using Git to the GitHub, to GitHub Repo or any other Git repositories that you have, you can configure your process in such a way that it will cause pre-commit, and pre-commit will do it based on your on what do you want to do with it. So each company decides how they want, each developer decide how they want to work with it. So you have a set of tools. I added them here because that's actually what I always using. So I work with Black, I work with mypy, I work with pylint. There is as well Flake 8 as a linter. So pylint and Flake 8, they show you whether any, let's say, syntax errors in your code. They highlight if your line of code is too long, or they catch all the things. And Black and mypy, they're more like code formatters. So actually what they can do for you, so if you run something in Python and then you just run black, they format the code for you any way that you want. So it's more like the how you call it? Yeah, it's more useful things and useful tools. And for me, the pre-commit is must-have because it catches the code that doesn't look good. And for example, if I have type hints all over the place, and mypy and together with black, then can warn me whether any problems appear. So it's really, really, really powerful thing as well. Yeah, do we have anything else? So yeah, this is like briefly to cover like the quality test tools, but there are even more to it. So yeah. Okay, let me check what we have as well. Yeah. Do we have anything extra? And also what I want to add, when you start work in a team on some specific project, you always define within a team what you're going to use, which tools are going to use. And then when you can say, okay, for these things, we are going to use conda environment, or the team decides to use only virtual environments. And then you say, okay, for the test, we are going to use Pytest because it's one of the, let's say, biggest library that we have for tests. So we go, okay, this is Pytest. And then it's up to you and your things to decide like what to do. Mm-hmm.
Like favorite pieces of code to reuse code. Mm-hmm. And then like saving functions in a Py file and import them. Mm-hmm. Oh, here we get a bit more.
Yeah.
And reuse this already factorized code in a previous notebook to clean and refactorize a new notebook?
Yeah, it's really good question. So now thinking Cecile, now I got like the whole path. So first of all, if you get used to work with Jupyter notebooks or Jupyter Lab, so if you're working with Jupyter notebook, I recommend you to make a step forward Jupyter Lab. Why? Because in the Jupyter Lab you have all the things like this. Let me show you. For example, you can create, first of all, you have an access to terminal right here, and you can as well create a text file. So for example, when you refactor something, what you can do, you can keep, there is a possibility to split, not close, new view for file. Yes, so you can split the window this way. So while you're in Jupyter Lab, so you can look at this, you can like make copy stuff, you can write some functions here. That's the one way. Another way, it's not a widget, so there is an extension to the Jupyter notebook, and actually you can run it in Visual Studio Code. This is actually what I'm doing. So I had in Visual Studio Code a Python thing that allows me to run any stuff. Just wait, it will be. This is actually how your notebook looks like in real life, and this is when you got it. Okay, so I'm Visual Studio Code, and this is Jupyter Notebook, and there is a thing with one line, with one touch of button, you can just easily convert the whole Jupyter Notebook to the Python script, or you can do it as well from here. It gives you a possibility from file. You can, it seems to me, export notebook as, and there are different options what you can choose. And there is a thing, it says, because I'm talking about, let me close this. So if I'm in the Jupyter notebook, it allows me to export notebook as executable script, and you touch it, it will be .py file. And then you're working with Python scripts. Then you can import. So you create a function, you write a function, and then you do something like this. For example, you write your own function, and we call it magic number. So then you say from, and then you give the name of the file. Now we have it's not a Python script, it's a Jupyter notebook file. So imagine that we have a Python script with the same name. That's why you will be doing something like from Jupyter refactoring workshop, import and then you give the name of the function, like magical number, or I don't remember how to call it, magical number. This will be your actually use case for the whole like how to optimize process. Yes, I agree. It's really a lot of work to optimize the whole process, and that's actually the main goal of refactoring. If you have just a Jupyter notebook with just a code without any functions, it's really hard to reuse it. Usually, what you're doing, you copy a cell, and then it doesn't work because it has some dependencies on another cells, and then you're spending 30 minutes to troubleshooting what's wrong with this cell. And if you have a function, it's much more easier. You can just copy this function in a file, and then you can import these functions for all other your Jupyter notebooks or other scripts. This is actually the main idea of reproducibility and modularity, that you can, and reusability, that you can reuse this function again and again and again. Okay, I think if there's no question anymore, we will finalize it. So this is my, yeah, you can find me on LinkedIn, or you can find me, we have as well a PyLadies Slack channel, where the PyLadies from all over the world can help you answer your questions. So this video will be recorded, sorry, it's already recorded. It will be published on our YouTube channel, and the link to this video, so you can rerun it, rewatch on your own way when you need it. It will be added here to the usage as well. I take a look on the Makefile for Windows. I will check it again for you. So yeah, the one thing that I want you to take away with you, that when you are writing something in Jupyter Notebook, please take care of future you and take care of the people who will be working and reading your code. So try to think what parts of the code you can reuse later. And it's much more easier to have nice and clean notebook than a big bag of mess. Thank you so much for your time. If there is no more question, then we'll stop for today. And remember, there is a solution folder that will be waiting for you. Luca and Ufuk, can I ask you to unmute yourself and just to say goodbye for everyone? This is our tradition with Demi. Yeah, so yeah, go on.
Goodbye.
Ufuk?
All right, guys. I hope you had fun. See you next time. Bye-bye.
Bye.